All right, so this is an attempt to understand Kadane's algorithm. All right. So one of my friends happened to ask me this question, right? He actually asked me to solve this problem called maximum subarray sum, right? So this is a famous problem, and the root solution for this problem is of order n square, which we all must have been able to code, right? But the optimal solution comes from Kadane's algorithm. Optimal solution, that is O of n solution. And this thing is not very intuitive at first. It is not very intuitive. So when I first learned this algorithm, I actually didn't go that much in depth. So eventually I happened to forget it. And when my friend asked me to solve this question using the optimal approach, I was not able to solve this question. So the question is pretty straightforward, that we have been given an array and we have to return maximum subarray sum. So it's very clear that this subarray right here will have the maximum sum, that is 2, 3, 4. But we have to report this sum, that is 9, in O of n time complexity. So this is an attempt for me to remember how I understood this problem or the optimal solution, the Kadane algorithm, and this might help others as well. So let's see. So let's say if I have an array, let's consider the same array, that is minus 1, 2, 3, 4 and minus 10. Okay. So what happens if the array size is 1? Let's say if this was my array size, what would have been the maximum subarray sum? It would have been minus 1. If this was my array, let's say minus 1 and 2 was my array, what would have been the maximum sum? Clearly 2. How come 2? The possibilities of the subarrays are either 1, either 2, or 1 and 2 together. So we wanted to return, out of the 3, we wanted to return the maximum. But if I somehow find a way to find out the maximum sum of any subarray that ends with minus 1, then I have two choices. I can either add 2 to it to know the maximum sum of the subarrays that ends with 2, or I might report the only answer as 2, eventually starting up a new subarray from 2. This is quite tricky, so let's do it again. Okay, so at first I was not able to digest the fact that how will I be able to code this solution, because I actually tried to learn the solution and not understand the solution, and it happened to be a bigger problem. So I'll write one statement and then we will try to uh, solve this problem, or try and understand, get a better understanding of the problem, like what it states. So to efficiently or to understand Kadin's algorithm, there is only one statement. What is that statement? It is, we need to find maximum sum for all the subarrays ending at a particular index. So what does this statement mean? See, if it is possible for me to somehow formulate a result up till this 3, that if I can find the sum of all the subarrays, the maximum sum of all the subarrays that are ending with 3, okay? So if all the subarrays they are ending at 3, what I can do is, if I plan to find out the maximum, what can be the maximum? Okay, once I include this 4. So I have two possibilities, right? I can either include this 4 in the sum of the maximum subarrays up till this 3, okay? Since we are considering for each and every element the ends, right? We are considering each and every element as the end of a particular subarray, and the next element can be added or it can start a new subarray. So there is no discontinuity as such in the results. So that is to be kept in mind, right? So if I have the maximum sum of all the subarrays ending with 3, ending with 3, then for the remaining array, for the remaining, let's say if I'm at 4, what I can do is I can either add 4 to this sum, okay, whatever is the maximum sum, or I can start a new subarray from 4. So this is very important concept to understand Kadane's algorithm. So we will do a dry run and then we will understand like what I meant to say once I asked you to calculate the maximum sum for all the subarrays ending at a particular index. All right. So let's see. So if, let me just write down the array once again. So this is my array, right? -1, 2, 3, 4 and -10. For this one, what is the maximum subarray sum ending at 1? For all the subarrays that ends with -1, it is clearly -1. For this two, okay, what is the maximum subarray sum for an, what is the maximum subarray sum for an subarray ending with 2? What are the subarrays that are ending with 2? It is this 2 itself and it is this -1 and 2. Okay, so what can I do is I can simply add this 2 to the previous maximum sum of a particular subarray that was ending at -1. I can add -1 to this 2, or I can start a new subarray from this 2, because this itself is the maximum sum for all the subarrays ending with -1. For this 2, I have a possibility. I have two possibilities. I can either include it in this sum or I can start a new subarray from this. So if I add it to the previous maximum, it becomes 1. Or if I plan to start a new subarray, the sum becomes 2. So what will be the maximum of these two? It will be 2, right? So over here we write 2. Or if you did not understand what I did over here is simply I went over -1. I asked -1 that -1, what is the maximum subarray sum for all the arrays that ends with u? Okay. If I had numbers over here, whatever numbers will be there, all that will be computed and will result into -1, because we don't have anything over here. So we just compute -1 as the maximum sum for this subarray, right? Ending with -1. Now for this 2 to be included in this -1, I have two possibilities. We want to find out for this 2 what is the maximum sum for all the subarrays ending at a particular index. For ending, let me just make some indexing, 1, 2, 3, 4. So for this one index, I want to find out the maximum sum of all the subarrays that are ending at 2. So the subarrays are 0, 0, 1 and 1 only, right? Because these are the subarrays that end at 1, right? There is no other possibility as such. So for these two, what is the maximum? It is -1 plus 2, or it is 2, and we have to report the maximum. All right. So eventually, if I have the maximum of the previous index, what I can do is I can simply calculate the possibilities. Okay. So we will do it for a higher index, and then you might understand what actually is the problem. So now for this 3. Okay, let's try. What are the subarrays that end at this index? 0, 1, 2 1, 2 and 2 itself, isn't it? Right? So what is the sum for 0, 1, 2? Minus 1, 2 and 3. If I add these up, what is the answer? It is 4. For 1 and 2, it is 2 plus 3. What is the answer? 5. For only 2, the answer is 3. Which of these is maximum? 5 is the maximum, right? So what does this mean? This again brings me to this. I already have this calculated for all the subarrays ending at index 1. What is the maximum sum possible? 2 is the maximum sum possible. So if I already know, I don't have to do all of these calculations. I can simply find out the maximum for 2 plus 3 or 3 itself. Okay, right? So this will eventually give me this 5. So this means for this 3, for all the subarrays ending at index 2, the maximum one, the array with the maximum sum is 5. Okay, so now let's consider for one more test case. All right, let's see now. This will get more and more clear, I assure you. So now we are at 4. Okay, so what are the subarrays that end at index 3? 0, 1, 2 and 3, 1, 2 and 3, 2 and 3 and 3 itself. Okay, uh, I think I forgot to include 3 in the previous case, right? One side. So 2 in the previous case. So now consider it from here. Okay, we'll also include the index itself. So these are all the subarrays that end at index 3, right? Let's calculate the sum. Minus 1 plus 2 is 1, 1 plus 3 is 4, 4 plus 4 is 8. So the sum is 8. Now 1, 2, 3 and 4. What is 2, 3 and 4? The sum comes out to be 9. For this one, 2 and 3. What is the for 2 and 3, the sum is 7. These are indexes, right? So these are indexes. What are we calculating? We are calculating the sum or the maximum sum for all the subarrays that is ending at index number 3. I hope I'm clear. So now if we include only index 3, it should be 4. What is the maximum of these? 9. Okay, so what is another way to report this 9 directly? What I can do is I go to this index 2. I ask this index 2 that index 2, what is the maximum sum of all the sub arrays ending at 2. Now index 2 says that it is 5. So what are the two possibilities? I can include 4 or I can start a new subarray. So whichever is the maximum, we go on and do that. As simple as that. So now for this 4, what is the maximum sum of an array or subarray ending at this 4? It is 9. Okay. But you might think, why are we taking maximum of 5 plus 4 and 4 itself? This will become more clear as we discuss a negative example. That is this minus 10 over here. Okay. Let's try again. So let me just erase this. Let's try it for index number 4. Okay. So what are the subarrays that end at index number 4? 0, 1, 2, 3 and 4. 1, 2, 3 and 4. 2, 3 and 4. 3 and 4 and 4 itself, right? 4 itself. So eventually computing the sum and finding the maximum. So what I can do is I will just calculate the sum. Okay, this is minus 11. Minus 11 and 9 is minus 2, right? 2, 3, 4, 5. This is 9. 9 minus 10 is minus 1. Okay, so what is another one? That is 3, 4 and minus 10. 3 plus 4 is 7. This gives me minus 3. 4 and minus 10. What is 4 and minus 10? It is minus 6. And what is just 4? It is minus 10. What is the maximum out of all of these? The maximum out of all of these is minus 1. So what is the maximum sum of all the subarrays that end at minus 1? End at minus 10 or index number 4? It is minus 1. Okay. So let me just clear this mess that I have created, and it will be more clear after this. Okay. I hope I have done all the calculations right. So this becomes minus 1. Okay. Now as you can see, we have what we have to do is we just have to find out the maximum of all of these. Okay. If we find out the maximum of all of these, that will be 9. That is our subarray sum, as you can see. So this is very simple and systematic understanding of Kadane's algorithm that you can get. Alright, so what have we done over here? This is minus 1, right? So there were two options. We could have come to this minus 1 with two ways, right? We could have also considered the maximum of this plus the current and the current number itself. So we could have considered the max of 9 plus minus 10 and minus 10. Okay, but it is very important to compare it with the number, because if the previous sum would have been negative and this number would have been a large positive, so the negative sum doesn't matter. So I'll discuss another test case to make it even more clear. Okay, so let's see. Let's include 4 indexes: minus 1, minus 2, minus 3 and 6. Okay, so eventually the maximum subarray sum is 6, right? As you guys can see. Now let's try and understand it. Okay, so we start. What is the maximum sum of all the subarrays ending with minus 1? It is minus 1. What is the maximum sum of all the subarrays ending at index number 1? Sorry, index number 1. What is that? I can either do minus 1 plus minus 2, or I can just say minus 2. So minus 1 plus minus 2 is minus 3. So this only becomes the maximum. Now for this minus 3, I have possibilities. I can do 1 and 2, I can do 0, 1 and 2, or I can do only 2 itself. Okay, so what I taught you before, we'll simply add these two up. Okay, and we'll compare it with the number itself. Okay, so what is minus 2 and minus 3? It is minus 5. Okay, now I compare it with minus 3, which is maximum. Minus 3 is maximum, so minus 3 will be the maximum sum of all the subarrays that end at index 2. Minus 3 is the greatest among all. Now comes the catch. Okay, so why it was necessary for us to compare the number itself and the sum till now is, now you'll get a clear understanding of why I had to compare the number itself every time. So for this 3, for all the subarrays ending at 3, what are the subarrays that end at index number 3? 0, 1, 3, 1, 2, 3, 2, 3 and 3 itself, right? Now as you can see, what is the sum? Minus 6 plus 6, that is 0. Okay, 1, 2, 3. What is the sum of 1, 2, 3? That is 1. What is the sum of minus 3 and 6? That is 3. What is the sum of only 3? That is 6. So eventually, if the previous sum was negative, right? If the previous sum up till this index was negative, what I could have done is I could have calculated minus 3 plus 6 and 6. What is the maximum of this? 6. So we can directly report 6 by comparing these two numbers. Okay, so this is why it becomes important to compare the number itself and the sum of the previous maximum, and after adding the next number to it. Okay, so this tells us whether we want to use the previous sum and include it in the current number, or we plan on to start a new subarray from this. Because eventually if I add this minus 3 and this 6, and if I try to continue the subarray that had minus 3 as the maximum sum, what will happen is I'll end up with a lesser sum, right? So that's why it is very important to always check if this new index is giving a possibility for a subarray with a maximum sum or with a greater sum, right? So this is it. This is a clear explanation of Kadane's algorithm, like why it is working. So you can go on and try and code up a recursive solution to solve this problem. So, or you might also write a tabulation solution to solve this problem. This eventually becomes a dynamic programming problem. But at the first sight, this is not very intuitive problem, and it requires you to look at its solution and analyze and understand and maybe not remember like I did, and it will not do justice to this beautiful algorithm that has been discovered to find maximum subarray sum. So this is it, and I'll eventually code this solution up for better understanding. Okay. So we just have to report the maximum of all the maximum sum of all the subarrays ending at a particular index, and eventually we'll end up finding the maximum of these, and then we can report the answer. As simple as that. All right. Thank you all.